Bon dia a todos. Welcome back to the new season of the CLUL seminars with our first guest who is here, thanks to Professor Alina Vilata, which is Adam Ussishkin from the University of Arizona, who is going to give a talk entitled Tuning the Lexicon, Evidence from Priming in Maltese. And I'm now going to thank you very much for being here with us. Alina, could you please?
Yes. Well, thank you, Adam, in the first place, for being here. It was luck that brought you here, really, and our meeting in Zadar, in the morphology meeting. I'm briefly presenting him to those who don't know him. He's a linguist. He had a background, a PhD in California, Santa Cruz, right?
Yeah.
In phonology, formal phonology and formal morphology. Then he moved to, and a specialist in modern Hebrew, right? And then he moved to the Department of Linguistics of Arizona, at the University of Arizona, where still he is, since 2001. And he also collaborates with the Department of Middle Eastern and North African Studies in Cognitive Science, the Department of Cognitive Sciences. He is now working in psycholinguistics, mainly on lexical access, and that is what he is bringing us today. Thank you very much. And I leave you to Adam.
Thank you. Thank you for the kind introduction, and also thank you for having me. It is pleasure to be here. So thank you very much for organizing this. So I'm going to be talking today about Maltese, but first just a note of thanks to all of my Maltese colleagues and friends who have helped me over the last more than 20 years now as I've started digging deeper and deeper into what I think is a really interesting language. Part of my goal today is to show you why I think Maltese is a really ideal testing ground for some of the questions that psycholinguists are interested in. So I'm going to be focusing throughout the talk today on word recognition. As we know, depending on the modality, word recognition involves an orthographic or acoustic signal that maps onto a representation in the lexicon. Lots of factors can influence the speed and accuracy of this mapping, and one of those factors is morphological structure, and most of what we know about how it works comes from languages that are very well studied. I have called them overstudied here just to draw a contrast with other languages because I really appreciate linguistic diversity and cross-linguistic endeavors. So the research questions that I'm going to be attempting to address in my talk today are the following. Can morphological structure be relevant even when it is relatively more abstract? And in particular, what I'm going to be using as my empirical basis for this is the root and pattern morphology that we see throughout the Semitic group of Afroasiatic languages. In particular, can the highly understudied Semitic language Maltese shed any light on this issue? So I'm going to begin by giving a brief background on root and pattern morphology, a little bit of background on what priming is, which is the primary technique used in the experiments that I'm going to talk about, and a little bit of background on Maltese. And over the course of 3.5, I'm calling it 4, but experiment 4, spoiler alert, is maybe we won't have time, and it's also sort of like my weakest part in this whole endeavor. But we're going to be asking the question, how Semitic is Maltese with regard to morphology and lexical access? I'll try to motivate the reason why we would even ask that question a few slides down from now. So in the first experiment, I'll address the question of whether roots facilitate lexical access by presenting results from an auditory masked priming experiment. In experiment 2, we're going to then turn, so as we'll see in a few slides, I'll be talking a lot about morphology as this sort of confluence of form and meaning. And so I'm going to try and get at these morphology questions with some experiments that are specifically designed to tease those things apart. So in the second experiment, we're going to ask whether morphological priming effects are at all driven by form. Again, I'll be presenting results from an auditory mass priming study I did. And in the third experiment, we're going to switch to the visual modality, again to look at this question of the potential role that form might be playing here. And finally, in the fourth experiment, we're going to look at the other side of the coin, which is the potential contribution that semantics might make. This is a sort of computational modeling study. And we'll conclude. So, a brief overview of root and pattern morphology. Many of you may be familiar with this already, but just in case, in Semitic languages, most content words are built out of two morphemes, the root, which is typically composed of 3 consonants, and the word pattern, which specifies the vowels and the relative ordering of consonants and vowels, otherwise known as the prosodic structure and the syllable structure. And this is something that linguists have been obsessed with for centuries. You can find medieval, Arabic and Hebrew grammarians who recognized these properties of these languages. In the sort of modern 20th century context, the most well-known approach to this comes from work by John McCarthy, who proposed a formalism to represent these different elements that compose words in Semitic languages. So here I have what that might look like for a Maltese verb like kiteb, which means he wrote. If you've read McCarthy or any of that work, you probably know that the most oft-used root to exemplify this is the KTB root. So I'm sort of sticking with tradition there, just for the sake of familiarity. So in red, we have the consonantal root, and then the word pattern, which consists of these 2 subparts, the vocalic melody, which tells you what vowels are in the word, and the CV template, which tells you where the consonants and vowels are with regard to each other in the word. And so the idea behind the McCarthy-type formalism is that each of those 3 units is presumed to be a lexical item, and then the job of the grammar is to combine those things. And then there's a sort of spell-out type of process that linearizes this to get from that representation with the association lines to the actual word kiteb. Okay, and this can do a nice job of accounting for morphological families in Semitic languages. So here are some other examples from Maltese where the root KTB is also instantiated. And I've kept the root highlighted in red so that you can see it. And just in case it wasn't clear, let me make explicit what makes this type of word formation process relatively unusual if you're used to looking at concatenative or linear morphology in languages like English, which is the fact that the root morpheme is distributed throughout the word, right? So typically concatenative affixation, you don't start another morpheme until you finish the morpheme you're on. So there's this sort of like beads on a string analogy for how you put things together. Semitic doesn't work that way. Or at least this part of Semitic doesn't work that way. I will also say, just as an aside, that in every Semitic language there is also prefixation and suffixation. Those types of processes do exist as well. But especially for the derivational morphology, this is the typical state of affairs. Different formalisms have been proposed to account for these patterns. I already mentioned the root-based approach that McCarthy takes. So under that approach, the lexicon stores consonantal roots and word pattern morphemes, and the grammar derives words by combining them. So consonantal roots and CV templates are the explanation for this behavior. On the other side, formally speaking, there are also word-based approaches. I'm responsible for some of those going back to work that started in my dissertation and continued for a few years. P.S. I no longer think that that stuff works very well for this, as we'll see from the experimental results that I'm going to present. But there are still plenty of formal linguists out there who are staunch defenders of the word-based view, which claims that the lexicon stores whole words or stems, and that the grammar derives words by affixation. So under that model, the root and pattern behavior that we see is epiphenomenal. If you'd like me to talk more about those approaches in the question period, I'm happy to. I developed a very pretty complicated formal structure within the model of optimality theory to account for this. And the reason at the time that I did that was because my goal was to show that root and pattern morphology wasn't really anything special. So I took that approach very seriously in that early work of mine in order to try to say, these languages are just like every other language, and the root and pattern behavior that distinguishes them is a result of different constraint rankings in the grammar compared to concatenative types of morphology. Okay, so just so you understand like the contrast between these two approaches. Switching now to the work that I do as a psycholinguist, let me just briefly give a background about some of the techniques I'm going to be presenting in the experiments that are coming soon. So in the experiments I'm going to present, they all use the lexical decision task. So in a lexical decision task, you have native speakers of the language that are presented with stimuli, either visual stimuli that are printed things on the computer screen, or auditory stimuli, which are pre-recorded sound files. And each time the participant's job is to decide as quickly and as accurately as possible if the thing they were exposed to is a real word of their language or not. Obviously, to make that ecologically valid, half of the items are real words, the other half are non-words. And we measure things like how accurate they are in their responses, and we also measure how many milliseconds it takes them to execute their decision by pressing the yes button if they think it is a word, or the no button if they don't think it's a word. And we select our real word targets according to the hypothesis we're testing. Typically we discard responses to non-words, not always. And in addition to that, we also, when you add priming to this, it means that there's a preceding stimulus before the presentation of the target that this participant is responding to. So priming, the reason we do this is because we know that exposure to one stimulus before a target stimulus can influence a participant's behavior. In particular, it can change their accuracy, it can change their response time, depending on whether or not there's a relationship between the prime and the target and what that relationship might be. The oldest and most robust priming effect in the visual modality and in the auditory modality is what we call repetition priming or identity priming, which is when somebody is presented with stimulus X as the prime, and they're presented right after that with stimulus X as the target. As you may suspect, the response time will be faster because they will have already been exposed to that target item when it was presented as the prime. We see these effects, by the way, when the prime and target are presented sequentially, but we also see these effects when the prime is presented 100 stimuli before the target, right? So it's clear that there's activation of some representation in the lexicon that enters working memory, and you can use that working memory representation to induce a faster response time to the target. But there's other types of priming as well besides repetition priming. So for example, you can have a prime-target pair that share a semantic relationship, like maybe they're synonyms or maybe they're semantic associates, right? In that case, people are typically faster to respond to the target compared to when the prime is unrelated. There's also what we call form priming or phonological priming, where some subset of the letters or sounds are shared between the prime and the target. And then, of course, the most exciting kind of priming at all, from my point of view, which is morphological priming, which is when the prime and the target share some aspect of their morphological structure. Okay. Did I explain that clear enough? Is everyone good on priming? Okay. Now, the coolest part of priming is that it can occur even if the prime is presented in such a way that it's not consciously perceived by the participant. This is called masked priming. I do have demos, but the sound is not really working, so I'm just going to have to use my words to describe this. But I do have lots of sound files that I'm happy to share with people later. The idea here is to subtract out of the processing equation this working memory component, right? If priming effects are solely due to the fact that there's a representation that's active in working memory, it reduces our ability to attribute priming effects to these linguistic structures that they might share. So with the visual modality, the way we achieve masked priming is by presenting the prime at such a fast duration that the participant isn't aware that it appeared on the screen. For auditory masked priming, I'll describe that a little bit later because it's complicated enough that it will get its own slide coming up. Outside of Semitic, we see some really intriguing early results from the 80s showing that even in languages like English, where we have, I would say maybe the closest thing to Semitic roots are the strangely behaving bound roots of English. So Karen Emery ran a remarkable series of studies in a 1989 paper that I recommend everybody read. And basically, what she found for auditorily presented primes and targets without any masking is that if a participant is exposed to a prime like the English verb receive, followed by the target deceive, their response time is speeded compared to when the prime is a control word that is unrelated. She did some nice control work in her studies to show that this wasn't due to simply form sharing between receive and deceive. Not only do they share a putative morpheme, but they also share a lot of their sounds. But balloon did not prime saloon in her study, and there's no morphological attributes shared there. This work was replicated later on in the visual modality by Forster and Azuma. So, there's already reason to believe from a language like English that relatively abstract morphological structure could be stored in the lexicon based on these results. If we go now to within Semitic, there's a vast and really impressive literature in Hebrew and Arabic. These are two very well-studied languages. Most of the Hebrew work that I'm referring to comes out of Ram Froth's lab in Jerusalem, and in a series of papers consistently showing that using masked visual priming, Hebrew readers show speeded response times when the prime and the target are built out of the same consonantal root. This is true for nouns, it's true for most kind of verbs, and they've done a lot of work in Hebrew to try to explicate whether this is based on shared form or meaning, and at least as far as meaning goes, that doesn't seem to be playing any role, and I'm mentioning that. I'm priming you for what's coming at the end. For Arabic, there's another remarkable set of papers by Sami Boudelaa and Boudelaa and Marslen-Wilson, also finding consistent effects of root priming for native readers of Arabic. And we can add a little bit of Maltese to the mix. I'm actually very proud of this result. Alina Twist, who was my first PhD student at Arizona, did a visual masked priming study on Maltese verbs and again found root priming. So the interpretation that we take from these results is that readers of these languages recognize words via their roots. I do want to say a word about the other side of the root and pattern coin, which is the word pattern, right? As it turns out, evidence for word patterns as a morpheme is a lot more fragile. It's really hard to find. We've looked for it over and over, and I have never yet found it. And then there are some conflicting results from Hebrew and Arabic, which I'm not going to have time to talk about today. In a recently published edited volume, I have a paper on Maltese pattern priming or lack thereof, so feel free to look that up. By the way, this is my first time putting QR codes into a slideshow, so I hope it works if anybody wants to scan that or any of the ones that are coming up soon. Okay, so, and I can talk about that more in the question period, because as you're gonna see, most of my talk is gonna be about roots. So if you're sitting there going like, what about patterns? I can say a little bit about it later on. I'll be happy to. Okay, here's a consistent complaint that I get from reviewers when I submit a paper on Maltese auditory word processing. Why are you bothering with the auditory modality? My gut response to that is well, I'm a phonologist, number one. But there's a lot of other reasons why we might want to care about auditory word recognition as well. But if the results from visual processing are so convincing, why bother studying auditory processing? Well, when it comes to Semitic, I think this is a really important thing to address. So in Semitic languages like Arabic and Hebrew, if you're studying the visual modality, your participants are obviously literate, right? And the interesting thing is that the orthographic system of these languages is pretty much an abjad system that represents mostly just the consonants, right? So the orthography directly cues the morphology when it comes to these languages. And maybe that's not an accident, right? Like maybe that's why those orthographies developed the way that they did, right? I don't know enough about the history of orthography, but like that would be consistent, right? So studying auditory processing is a strategy. It's one way to get some distance from that possible confound, right? Studying Maltese, and studying Maltese even in the visual modality, is another way. By the way, another consistent complaint that I get from reviewers when my papers get rejected is, why are you bothering to study this understudied language? As a linguist, I find that like deeply hurtful and insulting. Like, I'm coming from the other point of view. The fact that Maltese still is spoken by 500,000 native speakers is like a complete miracle of historical accident. It's wild. I'm going to tell you a little bit about it right now in order to sort of justify my interest. So I didn't take this beautiful bird's eye picture, but that's Valletta, the beautiful medieval capital that was built after the 16th century siege of Malta that everybody is very familiar with. I probably don't need to give the following slides to this audience because you all live in this region of the world, but where the heck is Malta, right? So here's a Google Earth image of the part of the world we're interested in. We're zooming in now. You can see on the left side the coast of Tunisia. Up there, that little triangle there is Sicily, and between them you can see a couple little rocks. That's where Malta is. If we keep zooming in, we get to this. You can see that Malta is composed of a main island called Malta, the slightly smaller one on the northwest, which is called Gozo, and the one little tiny rock in between, which is called Comino. So this is Malta. Here you've got a scale so you can see how big this is. And then here's like my favorite internet obsession right now is figuring out how to like convey the tiny size of Malta. So these are two maps that are exactly the same scale. On the right you have Malta, and on the left you have Tucson, which is where I live in Arizona. And you can see that like my little sort of medium-sized city in the United States, which has about, in that map there's about 1 million people, right? So twice the amount of people that live in Malta, more or less. And it's actually a little bit bigger area-wise than Malta. So Malta is really this tiny place, but linguistically it is absolutely phenomenal, and more people should study it. Interestingly, even though this is such a tiny country, there's a lot of dialect variation. So there's a standardized form of the language that most educated people speak, but then there are a number of regional dialects that vary from village to village. And Gozo, the other island off to the northwest, is like even farther away on the dialect continuum. And there's very little work on Gazetan Maltese, so like that's a really like ripe area for study, and sociolinguistically completely fascinating. So Maltese has had virtually no contact with any other Semitic language for about 1,000 years, since colonization by the Normans. So the Normans, you know, they conquered the British Isles, which is why my English sounds the way it does, right? But they also were down there and they conquered Malta. That was sort of near the end of the Arabic Empire in that part of the world. And from that point on, Malta was colonized by one European group after another. Malta just celebrated, in fact, a few days ago, its independence from Great Britain, which happened in 1964. So they've had 61 years of independence. As I mentioned, there's about 500,000 native speakers. There's also bilingualism. So every native speaker of Maltese pretty much is also a native speaker of English. They have their own variety of English called Maltese English. It sounds very, very different from my English, obviously, because I'm speaking like California English. And interestingly, there are 3 official languages of Malta. There's Maltese, Maltese Sign Language, and English. So English does have official status. It's the only Semitic language to use the Latin alphabet. And due to language contact, the vocabulary, and to a large extent the grammar, are evenly split between Semitic and Indo-European. The Indo-European is primarily from Southern Italian and Sicilian, and then starting with the fall of Napoleon, a lot of influence from English, because that's when Malta became part of the UK for a long, long time. So a number of the experiments I'm going to talk about exploit this interesting set of properties in this language. Another sort of just to try to like justify, like, why am I here talking about Maltese? In the theoretical domain, there's some really interesting work by Bob Hoberman and Mark Aronoff from the early 2000s looking at Maltese morphology, and they've got some choice quotes that just set me off 20-something years ago. So they say, Maltese verbal morphology, although it may superficially appear to be of the root and pattern sort, is in fact not. The best quote ever, Maltese is a concatenative language masquerading as a root and pattern language. And then they just sort of like lay down the gauntlet to people like me. This should be tested directly with native speakers using standard psycholinguistic techniques of morphological representation investigation. And starting in about 2004, I took that as a very serious invitation to get into this language. So the first experiment is auditory masked priming with roots. So in this experiment, we had 68 native speakers. This, again, was a lexical decision with priming experiment in the auditory modality. We had real word targets composed of verbs from the 4 most populated binyanim. Binyan is the grammatical term that comes from Hebrew that refers to a verbal word pattern. So for example, in Hebrew, there are 7 of them. In Maltese, there's like 11 of them. But these 4 numbers, and they, depending on what language you're talking about, they have different kinds of labels. So in Maltese, they have numbers. So they're sometimes called forms. Form 1, 2, 5, and 7 are the ones that are really well populated. They have enough items that you can actually like get an actual experiment designed. We also had an equivalent number of non-word targets as well as fillers in this study. Typical for this type of task, all of our participants were instructed to respond as quickly and as accurately as they could by pressing the yes button if they thought they heard a real word, or a no button if they thought they heard not a real word. We time them out at 1,500 milliseconds, and we measure response time and accuracy. And there's other experiments in this paper. If you're interested, you can go look that up. Okay, so how do we do this? How do we do auditory masked priming? So these auditory primes, they're masked. Participants are not aware of them. If you're skeptical of that, let me do my best to explain. So this is a technique that was developed by Kuiter and Dupuy. They published this paper 20 years ago now, and it was really life-changing for me because I'd been looking for something like this, but I'm not like that level of speech scientist that I could come up with that on my own. So it's designed to be analogous to the more well-known visual mask priming technique. Basically what you do is you record a bunch of words, right? They're all in their individual sound files, okay? So you're gonna structure your stimulus. It's gonna be composed of a prime, and it's gonna be composed of a target. It's also gonna be composed of a bunch of auditory masks, which I'll talk about in a minute. Basically, to mask the prime, you do a couple things. You take the sound file for that word and you compress it to 35% of its original duration, so it's really quick. And then you embed it in what ends up sounding like white noise or background conversation. I've recently given a bunch of like talks at conferences with a poster about this kind of thing, and so it's easy to say to people in a poster session, like, you know, all those other posters being discussed right now, like, just sounds like, you know, all this noise, but you're listening to my voice and you're tuning out that noise, right? So this is sort of what this is like. The masks are manipulated in 2 ways. The first thing we do to each mask is we compress it just like we do to the prime, but then we temporally reverse it, which makes it completely unrecoverable, and it just sounds like uninterpretable voices in the background, okay? A picture is worth 1,000 words. So this is a visual representation of what a stimulus, what a trial looks like. Time is on the x-axis. And you can think of this, and the waveform is up there, but really look at where it says target and what's under the target. You can think of that like 2 hands playing, you know, a piano piece at the same time, or 2 tracks if you're like a DJ or something like that. So the funny thing here says mask, but you can see that the word is squished together to represent the durational compression that we apply, and it's reversed. The order of the letters is reversed. So there's 1 mask before the prime, that's called a forward mask. Then there's the prime. Then there's the 5 backward masks. I know the term forward and backward is confusing when we're also doing a temporal reversal here, but those terminologies just refer to where the masks are with respect to the prime, temporally speaking. At the offset of the prime is when the target begins, okay? And the target ends before the masking ends, the masking noise ends. If you were to like not have all 5 of these, people get really freaked out if the noise goes away in the middle of the target. So we made sure that the masking always extends beyond the offset of the target. The other thing we do is we volume attenuate the track that has the masks and the primes, so it's softer, and the target is volume normalized to like just a normal sounding speaking voice, basically. I don't have any sound here, so I can't really play you the sound files that I have as examples of these. However, I can like send sound files if anybody wants to hear. Email me. It's not a big deal for me to just like send you some files. So don't think that if you're asking me to do that, that you're causing me any inconvenience. I love to share these things. I have examples from Maltese, obviously. I have some examples from English. I have examples from Hebrew. And weirdly enough, I also have examples from Scottish Gaelic, where we've also used this technique to further explore morphological relationships in the lexicon. Okay. Also, the script that we use to do this, you can get from that QR code or at that link. I didn't write the script. Several of my extremely talented PhD students wrote the prot script. It's a beautiful prot script because it has a great visual interface, and it also lets you, there's all these parameter settings you can do. What if you don't want to compress it to 35%? What if you only want to compress it to 50%? So write 50 in the little parameter space for that in the script, right? Do you want it volume normalized or not? Right? So the script is great because it allows for all sorts of variation in how you create these things. It doesn't just do the Kuiter and Dupuy thing. It opens up a bunch of dimensions that you can play around with. So it's very cool. So in experiment 1, our materials included prime target pairs that were identical, prime target pairs that shared a root, like the KBR root in this example, and then a control condition where the prime and target pair don't share a morpheme, don't share any form, okay? And the predictions here, pretty straightforward, right? If native speakers are using the roots at all, even when they're not aware of those primes in the speech signal, right, we would expect reaction times to the targets in the root-related condition to be faster than in the unrelated condition. And this was like the first time I ever like got like an exciting, graph, and I'm very proud of this result. So we have the numbers on the left, and then I have a sort of net priming graph. Let me just explain the way that this graph works. So in this graph, you don't see the control condition because it's basically the 0. 0 is the baseline priming. And the amount of, like, if one of these conditions is faster than the control condition, you'll see a bar go above 0. If it were like slower, you would see the bar go below 0. Does that visual representation make sense? Okay, so you can see that we're getting both identity priming and we're getting priming when the prime target pair are built out of the same consonantal root. And remember, they do not hear the prime. So we've done all sorts of like testing for prime awareness. There is no prime awareness. And interestingly enough, when you ask participants like, how do you feel you did on this, was this difficult for you? They're like, nah, I just tuned out all that noise and listened for the loud thing, for the target. And by the way, their accuracies here are comparable to their accuracy. So we did a companion study with no masking, with fully audible primes, right? Mean accuracy is like at 97%. In this study, mean accuracy is at like 95%, and there's no difference. So in case you were worried about that, we usually give them 10 practice trials before the test targets begin. And you can see on their faces for like the first or second practice trial that they're like, and then they just like habituate to it, and accuracy is at ceiling. So we feel confident about that. So at least based on these results, roots seem to facilitate word recognition. We need a level of morphological structure in our models of the lexicon. And so there's some support potentially for an abstract representation of these roots in the mental lexicon. So at least you might take away from this that, oh, this looks pretty Semitic, right? See what Hoberman and Aronoff have to say about that, right? Okay, let's talk about this a little bit more, because there is potentially other avenues of explanation for this, right? Maybe this priming effect is due to semantic overlap, right? We didn't have the luxury of being able to control for that in the study because we needed enough items to make an experiment. So maybe the fact that words sharing a root happen to be semantically related to each other, maybe that's driving this effect, right? Or it could be due to form overlap, right? Just because things share consonants doesn't necessitate that those consonants constitute a morpheme per se. Does everybody see the difference there? Right? So maybe the form shared between primes and targets is enough to produce this priming effect, which is equivalent to repetition priming, right? It's a reasonable objection here. Okay, so maybe that, yeah, that's what I said. So we tried to do some post hoc tests looking for form overlap effects. We didn't find anything. Maybe it doesn't hold water, but we need to go a little bit further. So experiments 2 and 3. These experiments are going to test whether these effects are due to shared consonants or is it really about morphology. Coming back to this recent paper I mentioned by Barabee and Boudelaa and Barabee and colleagues, they view these types of effects not as morphological in any way, but as evidence for consonant facilitation, and it has nothing to do with morphology, right? So how do you tease apart the possible effects of form from morphology, right? It's been done a little bit for Hebrew. So in one of the Frost et al. Studies, they did a really clever priming condition where prime target pairs shared 2 out of 3 root letters, as you can see in the example in the bottom bullet there, right? They didn't get any priming there, right? They only got priming when the full root was shared, right? Is that the end of the story? Well, 2 out of 3, sure, that's not bad, but what if we can do this in some way where there are 3 consonants shared between the prime and the target? And you might be asking yourself, how do you do that in a Semitic language? A root is a root. Well, the other question about semantics, we'll come back to in a minute, but I want to focus now here on a very special property of the Maltese lexicon, the fact that this language is half Semitic and half non-Semitic. Experiment 1, we only use Semitic verb targets for our materials, right? But the fact that half of the lexicon is non-Semitic actually opens up a whole new testing ground for asking this form-based question, right? And we can't see that in any other Semitic language. So how is it done? Well, we can look for Semitic and non-Semitic words that accidentally happen to share their consonants, right? But there's no etymological relationship. There's no morphological relationship, right? So Maltese has the word cobra, obviously borrowed from Italian, right? Which has the same 3 consonants as the Semitic verb kiber, to grow, right? There's also a way that we can start to get at the potential influence of semantics, although I'm not sure we really addressed it well enough in this particular experiment. But if you know Arabic, you know that most varieties of Arabic have a series of secondary articulations involving pharyngeal constriction, right? So you have like regular T and pharyngalized T, like that, right? So one of the sound changes that occurred in Maltese is that all those secondary pharyngalized consonants they all neutralized with their plain counterparts. And so one of the outcomes of that is that you get all these sort of like accidental families that aren't actually etymologically related, right? So that's why it looks like the verb sfar, which means to turn yellow, it's related to the English word saffron, obviously, right? But also, you find the verb safar, right? I don't remember which one had a pharyngalized S historically, because I'm not a good enough historical linguist, but like those 2 words share their consonants, but etymologically speaking, that's not the same root, right? So what happens when we prime with those things? So we tested whether prime-target pairs with these characteristics yield priming, okay? This is with collaboration with a bunch of excellent people, and I'll say more about the outcome in a minute, but we had 79 native speakers in this participant. Again, it was an auditory mass priming study. We had 96 real-word targets. We had many more this time because we had this extra variable that we were manipulating, which was the etymological source of the prime and the etymological source of the target, okay? So we had the same 3 priming conditions, identity, related, and unrelated, but related here means sharing consonants, not sharing a root, for the reasons I just went over, plus this other variable of whether the prime and the target were Semitic or non-Semitic. And we did all the possible all the possible pairings of these things. So I have this grouped first by what I'm calling within strata priming, which means the prime and target are both Semitic or the prime and target are both non-Semitic. And then I have across strata, where one is Semitic and one is non-Semitic or vice versa. Okay, does everybody see how that works? So if Maltese is like Hebrew, we would predict facilitation when Semitic targets are primed by Semitic. Sorry, when Semitic targets have Semitic primes because they share consonants, and in Hebrew, Frost showed that semantics doesn't matter, right? If it's strictly morphological, it's kind of a weird thing. We kind of predict a null effect, so let me show you what we found. We basically found a null effect. I don't want to overinterpret our null effect. But in each of these 4 panels, again, we have the identity condition on the left and the related condition, which means sharing consonants on the right. And there's a little bit of like numerical facilitation here or numerical inhibition here, but none of those effects reach anything close to significance. There's nothing going on here, right? So it doesn't seem to be the case that shared form alone is enough to do anything here. We're still getting identity priming, so that's good. It's further confirmation that the auditory mass priming technique is robust because we got these effects in yet another experiment. But across strata, between Semitic and non-Semitic, we don't find any priming. So this form overlap hypothesis, at least based on these results, is rejected, and Barabee, they have some work to do. I'll have some more criticism of their work coming up later. We also find no facilitation within strata. So the Semitic word sfar does not prime the other Semitic word safar. Interesting, right? Because those are both Semitic. So this result is different from the first experiment where we found robust effects of priming. We have a paper in progress that's up on SciArchive if you want to look at it, where we are doing some post hoc computational modeling to further explore the role of semantics here. You can look at that if you like. But now I want to turn to possibly the most exciting experiment. Even though it's in the visual modality and I'm a phonologist, I'm still very excited about this work. So I had this wild and crazy idea with one of my former PhD students. What if the primes are just the 3 root letters? Again, we're switching modalities now to the visual modality, right? So in Hebrew, remember, it's an abjad system where the orthography is primarily consonantal. Frost et al. Have already, like, they thought of this idea originally, right? They should get all that credit. That's a very clever idea. And they actually found for Hebrew that if you prime a Semitic word in Hebrew with just its 3 consonant letters, that you get facilitation. Now this happens both when those 3 root letters are a legal orthographic word in Hebrew, but they also found the effect when the 3 orthographic letters together are not an orthographic word in Hebrew, because there are some roots that are like that for Hebrew, based on the combination of like morphological characteristics and orthographic constraints, right? Grammatical constraints. But for Maltese, things are a little bit different. As I mentioned earlier, Maltese is the only Semitic language that uses the Latin alphabet for its writing system, which means that it writes the consonants and it writes the vowels, okay? And a string of 3 consonant letters in Maltese is not a legal orthographic word. There's no such thing, okay? There's no such thing as KBR. That's not a word, spelled word in Maltese, right? So it would be more surprising to find this effect in Maltese. You can probably tell where I'm going with this, so maybe you won't be surprised, but you can read about it there. Let's go into details. So again, we switched modalities to the visual modality, and we were going to look for priming when Semitic targets are primed by just their root letters, and we compare those response times to targets where the prime is just some unrelated set of letters, right? And then to assess whether this effect was due to morphological overlap, not just about the shared letters, right? We included an equivalent number of triconsonantal non-Semitic words in the experiment to really test like what's going on in the Semitic side and what's going on in the non-Semitic side. So the prediction here is that if root priming in Maltese is really due to accessing the morphological structure, we expect facilitated response times when the targets are Semitic, but not when the targets are non-Semitic. So we had 77 native speakers, and participants, judged the lexicality of 192 visual targets. We had 96 real words, half Semitic, half non-Semitic. We matched for frequency. We tried to control for word length, and each one had at least 3 consonant letters. And then we had a corresponding set of 96 non-words. We basically made up nonce roots for those, okay? Each real word target was matched with 4 different primes, a repetition prime like this. By the way, the letter X in Maltese is the sound sh, so this word is Fidesz. We had a root letter prime. Again, we just look for the triconsonantal root, extract that, use that as the prime. We also were interested in testing whether this effect might have just to do with like some shared form instead of total shared form. So we had a condition where we had 2 out of the 3 root letters as the prime and then a random letter. Okay, we did that as an additional control on the phonological side. And then we had a control condition where the prime consisted of 3 consonant letters that did not occur in the target word. And then each non-word target was matched with a single root letter prime, like in this example at the bottom. So this is what trial looks like in this study. So we have a forward mask of hash marks for the first 500 milliseconds, followed by the prime and lowercase letters for the very brief duration of 50 milliseconds, followed by the target item here. So assuming we observe priming in the root letter condition, if it's morphological, and if root letters are somehow represented in the Maltese lexicon in a way that allows them to produce a priming effect, participants should be faster to respond to Semitic targets when primed by their root letters, but not the non-Semitic targets. That makes sense, the prediction? Okay. If it's due to phonological overlap alone, we should find equivalent facilitation for the Semitic and the non-Semitic words when primed by their root letters. So here's the first set of results. This is the set of results for Semitic targets. Let's break this down. So we have numerical results on the left. This time I just have like raw data for all the priming conditions. This is not a net priming graph, but you'll see why when you see the next graph. So you can see the baseline condition on the left for control, and you can see this interesting like linear progression of facilitation, right? Repetition produces the fastest response times. 2 out of 3 letters produces faster than the control response times, and root letter, and then sharing 2 letters a little bit less, but they're all significant, okay? So you might be looking at this graph and thinking, oh, this is clearly about phonological form overlap, right? Because we see this like linear progression. The more material is shared, right, the greater the reduction in response times, right? The faster people are. Okay, so I don't know, I'm 50 minutes in, audience participation, what is the next slide gonna look like for the non-Semitic targets? Any guesses, even if you don't say it out loud, come up with a prediction in your head. What's it gonna look like, right? Is it gonna look like this because it's about shared form, or is it gonna look different? Well, I'll give you the answer. It looks very different, right? Everything goes away entirely. The only thing left is a repetition priming effect here, right? Shared form for the non-Semitic targets is not doing anything. I feel like this pair of graphs is like the only motivation we need to like keep digging into this amazing language, right? It tells us so much. So root letters prime Semitic words containing them in Maltese, but triconsonantal strings which are not roots do not prime the non-Semitic words that contain them. So actually, this seems like pretty good evidence that root letter priming is morphological, but it can't be phonological, because then we would expect to have found that in the non-Semitic targets. Again, the Barabi et al. Prediction is that the second graph should look like the first, right? They sort of acknowledge this paper in their paper, but they, I think, like fail utterly to explain away our results. I think our results are pretty robust. I realize that that's quite a bold challenge to make, and I don't mean it in any like way other than like we need more scientific inquiry to keep going on this, right? So the results here suggest that visual word recognition in Maltese is sensitive to morphological structures. So I think we have converging evidence from both the auditory and the visual modality about what might be going on here. And interestingly, these results suggest that these units have to be represented in the lexicon directly, right? Maybe Maltese readers have abstracted out and stored these things for Semitic root morphemes across their reading experience, right? Surprising given what I said earlier, right? There is a degree, there's an abstraction process that would be involved there, since these triconsonantal strings are not legal orthographic words in Maltese. And apparently, we can activate those very representations by exposing participants to them, even under masked conditions, right? They have no idea that they were there. I want to say a few words about this form overlap stuff that we found. So we did find some facilitation for Semitic targets in the 2-letter priming condition, suggesting that partial overlap can also activate these representations. The way we created these, we didn't expect to find this. I don't know, maybe we should have had more faith in ourselves. So we didn't balance items in the way that might have been more appropriate. So these kinds of primes consisted of 2 root letters with their relative linear order preserved, plus a 3rd letter, but we had 2 types of primes, right? One where the position of the root letters is the same, and one where it's disrupted. And we need to do more work to see whether this position variable matters, because we didn't control for this, so the items are not balanced in this way. Another interesting outcome of this experiment that we did not hypothesize we would find is that participants were faster to respond to Semitic targets versus non-Semitic targets by a good amount, like 30 milliseconds. That's in a visual word processing study, that's a lot of time for what's going on in here. Maybe the Maltese words that come from the Semitic part of the lexicon have more orthographic neighbors that might help if visual word recognition works the way it does for English with regard to neighborhood density. Maybe that could explain these results. So we actually did a post hoc analysis on that. We didn't find that it gave anything, so more work is needed there. Now, this question, again, we didn't anticipate, but one of the first times I talked about these results, a very, very smart person asked this question. So if we're just talking about the non-Semitic words for a second, forget about the Semitic words. What about non-Semitic words? There are 2 types of primes, right? For some of the non-Semitic words, the 3 consonants might correspond to a Semitic word, a Semitic root over on the other side, or they might not, as you can see in these examples, right? So like the word katuba, borrowed from Italian, means bass drum and has nothing to do with writing, but KTB, oh yeah, we already know that that's a Semitic root in this language. But the word for vaccine, vaccine, right? There's no root on the Semitic side, right? Did these behave any differently? So again, post hoc analysis, I don't want to put too much weight onto this, but we did go and test this with our unbalanced items here. We found an interesting difference in the root letter priming conditions. So again, recall that these are all non-Semitic targets, but the white bars represent when the 3 consonants correspond to a Semitic word, and the gray bars correspond to the ones where Semitic root, the gray bars are when they don't. You can see that people are slower when the 3 letters happen to correspond to a Semitic root. Ooh, that's got to be saying something, right? So a hypothesis, something we still need to test, so I'm just calling it hypothesis, maybe it's even a speculation, is that root letter primes correspond to a lexically represented unit. And when people are exposed to that, even under mass conditions, there's going to be automatic activation of the Semitic root family. But when the target that immediately follows that prime is not one of those things that got activated, but it's from the other part of the lexicon, right? They have to do some extra processing work and that's sort of going to manifest as this inhibition effect, right? Somebody needs to go do this and design the study where these items are balanced in the right way, okay? But I think that hypothesis is worth testing further. Okay, I know I'm running out of time. And it's also the weakest part of my talk. So I'm going to skip quite quickly through this, and you can ask me more about it. Because we need to end in the next couple minutes, is that right? Ish? Yeah, okay, good. So I'm going to breeze through this. If you want to ask me about it in the question period, I might be able to say a few things. Together with my colleagues Jessica Nieder and Ruben van de Pfeiffer, we've been interested in exploring whether or not semantic effects might be driving what we've been viewing as morphological effects. So what I've shown you over the last 2 experiments is that the morphological priming effects that we found, they seem to not have anything to do with form, right? The form does not seem to be active. I mean, the results we got from experiments 2 and 3 are consistent with a lesser or no role for form. What about meaning, right? There's a debate in the word processing literature about when we access the semantic properties of a word, right? So some accounts say, the form then meaning accounts say, you have to finish processing the form before you can process the meaning. And then there's the form with meaning accounts that say meaning can actually start being processed earlier on in the word recognition process. So what we did is we did a computational model of the results from the first experiment I told you about, where basically what we did was we ran a linear discriminative learning model to generate semantic representations that we then matched with a word embedding model, a BERT model. And we entered that as a variable into our priming data. And what we found, I'm going to skip through these details, I apologize, it's all in the interest of time. Our LDL model does pretty well. We entered a bunch of semantic variables based on the outcome of that model and used that to try to put those in as predictor variables for our priming results. And what we found was that for onset RT, there was an effect of semantic variable. So these are the 3 different priming conditions. I know this is too tiny, but unrelated is here, identity is here, and morphological relationship condition is here. And you can see that this line and this line are very similar to each other. In other words, the meaning of the relationship in meaning between the prime and the target is actually doing a pretty good job of predicting our response times. We get slightly different but similar kinds of effects when we look at the results that we measure from the end of the target, the offset response time. Again, I understand that I didn't go through enough details here, and I apologize. You can ask me a little about it in the question period if you want. But basically, if we represent semantic relationships between words using distributional semantic approaches and computational modeling to basically get like a quantification of the semantic relationship between the prime and the target, what we see happening is that the closer the semantic relationship between the prime and the target in the morphologically related condition, the faster people's response times are. So it looks like at least some tentative support for the notion that Maltese listeners are actually accessing the semantics of the prime early on, and that that's providing them with some form of facilitation for responding to the target depending on the degree to which the prime and target share a semantic relation, or how far apart they are semantically is a better way of saying that. By the way, you can also ask me about this in the question period. Hebrew doesn't yet seem to work that way. I can talk about that in the questions. So we see an interesting difference between Maltese, where it looks like semantics might be playing a role on the one hand, and on the other hand, in Hebrew, where when we try to do things in as parallel a way as possible, we're not getting any effect of semantics for Hebrew. Okay, so time to conclude. Semitic words in Maltese are primed by other words sharing the same root and by just the consonants in the visual modality. Semitic words fail to prime non-Semitic words, even when their consonants are the same, and vice versa. Form doesn't appear to play an important role. Early access to semantics might be explaining these effects. And I would submit that morphological structure is indeed important. So thank you very much, and I welcome any questions.